So from risks now, let's look again at some impacts and projections, and then move more specifically into some ecosystems within the risk scale we showed, and then move into mitigation and adaptation. This is another map that is a good example of how many different systems you have to think about. So the main message you want to emphasize is that projections of climate change are not just about temperature and precipitation. It then has to be cascaded into every component of the Earth's system, and including human systems and their interactions and human livelihoods, so that the mitigation and adaptation strategies can then begin to address each specific cascade that is possible, so that the models are also able to take those into account as the emission pathways are determined. So it's a very complex process, but just going through all the different combinations of systems in the Earth that we have to look at and the kind of impacts that are possible gives us a sense of just how vast the problem is. And then once you have the huge background, then you can go back and try to focus your course more appropriately and see what you want to emphasize. Maybe it's something very local, and that will become more clear as we look at some other impacts. So let's look at these impacts now, again on a global scale, and different regions and slightly different systems. So here we are going to look at fisheries, aquaculture, human health, and coastal tourism. Why do we combine these things in a different way? It's just that they are interrelated. So fisheries and aquaculture are interrelated because they are both part of the food system and a global economy. Countries like India and China, for example, are growing in aquaculture and then exporting a lot of their products from aquaculture. And some products like salmon, which are valuable for many cultures, are declining in the natural habitat, but also even if they are not declining, they can be farmed and grown more rapidly, and the supply can be increased by certain countries like Canada and Norway, for example. So in that context, coastal tourism and human health are also related. So it's just a different combinations of things. So here it is showing different regions. Let's look at one by one. Again, we don't need to worry about all the details, but just get a sense of how broad the issues are. So in the Caribbean and Latin American region, there are lots of indications of ocean acidifications and extreme events and flooding, because this is in the track of the hurricanes. So every year they get hit by various categories of hurricanes, and of course they are also very close to the most industrialized nation and a lot of the growing economies. So that's a hotspot for impacts on corals, agriculture, and aquaculture, and so on. And if you look at starting with system 1, which should be that one that we just looked at, system 2 is the ecosystem phase shifts between global and under climate change. So you have some species that are used to certain temperature range. So as temperatures begin to warm, some will move closer to the coast, because usually coastal upwelling has pockets of colder water than away in the ocean. So there is a coastward, landward movement, and then temperatures decrease as you go to higher latitudes. So some species tend to move poleward as shifts happen. So you can see that there is a global distribution of benefits and losses, but also poleward shifts in fisheries, and along with that comes tourism flows as well. So you have more and more ships going towards Antarctica, Alaska, and so on for curiosity, as well as economic growth also impacts those kind of issues. So there is always an intersection between climate change and the economic change, and so on. So disease transmission and ecosystem services also change, because as the warming expands, we mentioned before that mosquitoes begin to expand their latitude and altitude. So tropical diseases are now moving into higher latitudes, and so on. The low oxygen condition, we mentioned that deoxygenation with warming and with circulation changes is occurring in many regions, especially coastal regions. So you can see that the coastal regions in various places are beginning to show, even here there is deoxygenation and low oxygen conditions occurring. In an ecosystem sense, they begin to change the so-called predator-prey dynamics, which means the large fish that eat either the small fish or the zooplankton or whatever, they chase their prey into regions. If they are visual predators, they want to go where the waters are clear. Otherwise, the animals that dive, like big-eyed tuna, dive into lower oxygen regions and so on. So as you change the circulation and oxygen levels and production, you change the clarity and water quality, and that affects the predator-prey dynamics, and it will change the range of ecosystems and fisheries yield. So how much fish you can catch also begins to change. There are other changes in regions that are marked as 4, which include climate-induced landward and global and poleward and bottom towards the deeper waters, shifts in certain species because there is also colder water below the surface. So aquaculture of higher trophic levels, which means going from things like shrimp, which are pretty close to the bottom of the food chain, to fish like oil fish, sardines, anchovies, or tilapia and so on, which are also consumed, or cash crops like menhaden, or even upper levels like salmon, which is a very prized sushi salmon demanded by the Japanese, or there are also tuna farms in the Mediterranean and so on. So they are all getting affected by the warming as well as low oxygen conditions, and that begins to show higher mortality, and also productivity begins to go down. So mortality rate is basically related to temperatures, because species that live in colder waters typically tends to live longer and grow bigger. With warming, that mortality, which means their lifespan, begins to shrink. These are already occurring in some places as indicated here. The mean body sizes and biomass of fisheries that people like to catch and eat have also been changing. There has been a reduction in those, and they are projected to occur at low to mid latitude. So as temperatures change, remember that as warming happens, the solubility of gases also goes down, which tends to automatically also reduce oxygen in addition to deoxygenation because of circulation changes. So the ecosystem responses at individual level, like mortality changes and body size changes, versus ecosystem changes where one species moves and the predator-prey interactions change. All these things have to be looked at. So there is sensitive aquacultures to sudden and extreme weather events. So as storms are changing, as rainfall over land brings huge runoff and sediment loading into the aquaculture regions and so on, or ocean heat waves, they all affect these aquacultures, and they are also projected to increase into the future. Warming induced poleward shifts in diseases. So you can see there are places like number 8 is here and also here. So they are on the edge of the tropics right now. So things like cholera, which is induced by a bacteria called Vibrio cholerae, and the poisonous jellyfish called Irukandji, which is occurring in several regions. It's very poisonous, and it can create huge perturbations to water use by humans, sailors, and to other fish. And in general, jellyfish are more efficient at occupying low nutrient regions because they filter a lot of water and get nutrients, whereas if nutrients are reduced, other phytoplankton or fish or so on that need more concentration of nutrients cannot survive. So there is all kinds of expansion of habitats that are not expected usually. So there is projected changes in fisheries yields, changes in predator-prey dynamics. Sea level rise is going to affect the ecosystem dynamics, and surprisingly, as the Arctic ice melts, the exchange of fish and diseases between the Atlantic and Pacific is going to be increasing. So there are already indications that up to 41 species have entered the Pacific, and 44 species are expected to enter by 2100. So any non-native species that comes in will have what is called an endemic disease. So the fish that lives here has a certain pathogens that it carries, certain viruses, bacteria that it has, and when it moves to a new region, those species will not be used to the pathogen that this species is bringing over there, and the same for fish that are coming from there to there. So these are highly unexpected situations. So suddenly we realize that by allowing this pathway to be open, there is a huge commercial advantage, of course, because instead of going around like this, now you can cross into the Pacific this way. But along with it comes this exchange of species, which is not something that was easily foreseen before. So biomass stocks decrease, then you will have impacts on fishing activities. Lots of communities that have fished for centuries, like the Inuits in the cold regions, or even the artisanal fishermen along regions that are warming, and so on. And as for ecotourism or coastal tourism, loss of beaches from erosion and sea level rise are already impacting economies, but it's going to get worse into higher and higher latitudes. And there is a kind of competition between economic interests in bringing more tourists into regions, but also then worrying about how that affects coastal erosion, coastal structures, and so on. So lots of barrier islands that are very common along the east coast of the US, for example, are used as tourist spots, which means new hotels are built in, new restaurants, shops, etc., and they begin to affect the erosion rates, actually. So these kind of interactions have to be kept in mind. Looking more specifically at some of the things, if we look at the extinction rates in terms of percentages as documented by the International Union of Conservation of Nature, then there is a kind of a baseline extinction rate that happens with climate variability and climate change anyways, natural climate change. But you can see that over the last few centuries, many species of fish and vertebrates and birds and mammals have been going extinct. These are kind of percentages of their total estimated biomass. And the rates are accelerating. So you had a different rate here, acceleration here, and now further acceleration. So you can see in your own neighborhood or in your own region, how have sparrows changed in population? Were there more sparrows? Are there more sparrows now? Are the sparrows themselves changing? For example, there is some evidence that the wingspan of the sparrows is changing because they are now maneuvering through fast traffic and between buildings and so on, which I mentioned earlier on. And frogs were for some time kind of an indicator species for acid rain. A lot of lakes which had frogs began to be born with strange features like 5 legs and 3 legs or so on and so forth. Now they are also indicators of global warming and acidification. Not acid rain was related to coal burning, sulfates, and that being washed down, and now it's more of acidification, which is dissolution of CO2 into the water, and so on and so forth. And there is lots of work showing that some of the larger mammals are more susceptible to warming than some of the smaller ones. Some species are more easily adaptable and move with temperature more easily than some others, and so on. So this we looked at before. Global average impacts. We already mentioned that many trees and species will not be able to keep up with the kind of rate of change. So that's something you have to remember also. When we show temperature projections, we are saying 2-degree warming, 5-degree warming, and so on. And we are saying the warming increases with decades into the future, into 2100. But the rate at which it changes, degree centigrade per year, is important because some species can adjust if the change is slow enough. But if it changes very rapidly, then some species just cannot keep up. So it's not just how much change happens, but how fast it happens. That is also critical. So you must always keep that in mind. So many rodents and primates will not be able to keep up in this range of rate of climate change as opposed to warming or temperature change. And most carnivores and split-hoofed mammals cannot keep up when we get to this stage, like moose and elk and so on. So this overlaps with the habitat changes that are happening. How are the habitat changes happening? Basically, either we are deforesting and building human habitations, or temperature changes are making the vegetation changes and forests are not as thick, for example, let's say, or we are basically converting them to some kind of a protected area and trying to see if that helps maintain species. There are complications there, as we will see, is something called forest fractionation or fracturing of forests. So you build two neighborhoods into a forested area and keep some forest in between. You are basically going to change the connectivity between the two pieces of forests that you separated, or made it change in some ways, because some butterflies and birds may be able to fly, but some insects and some animals will not be able to go between two pieces of forests like they used to when it was continuous. So in other words, human beings are hitting the system at multiple levels: temperature change, precipitation change, vegetation change, deforestation, urbanization, conversion to agriculture, and so on and so forth. All those have to be considered together. This is a nice map that shows projections of changes in maximum catch potential. So it is like how many tons of fish there is in any given region. So if you take a region which is very well known for a species of tuna, temperature change, acidification, etc. is going to change the predator-prey dynamics, body size, mortality, and so on. So the net result is going to be a change in the catch potential. That's the maximum available yield from that region. So wherever there are red areas, this is potential catch change from 2001 to 2010 period, going into 2051 to 2060 period, and the scenarios were actually taken from the previous IPCC projections because of having too few models and so on. But nonetheless, forgetting the details for the moment, you can see that there are large tropical regions where there are huge negative changes in projected potential fishing yields, and also in the Southern Ocean. Southern Ocean is a massive region where billions of tons of krill grows, which is like a small shrimp. That's important because some of the whales that live way to the north actually migrate all the way to the south to arrive there in the southern spring, so that they can feed on the krill population. So krill is like a little shrimp, as I said, and whale is bigger than a bus. So the whale just swallows millions of gallons of water, spits out the water and keeps the krill. And they come there when they are having babies, because krill is a very nutritious food for whale babies. The lower you eat in the food chain, the more nutrition there is, because as you go up in the food chain, the energy loss happens. The energy transfer efficiency is only about 10% typically. So that applies to us as well. If you eat vegetables and fruits and vegetarian food, you are closer to the lower end of the food chain. But as you eat meat, especially beef, the nutrition content is very low per kg of food, and to grow 1 kg of beef takes much more land, water, grains, and so on compared to growing vegetables. So that works for whales and anybody else as well. But this is like us eating ants. How many ants do we have to eat to feel full? So that's how many krill the whales eat. So the tropics, as we call the global south, are highly susceptible, and as the warming happens, some of the higher latitudes will actually benefit, and they will see new species moving in, or the fish probably growing larger till the optimum temperature is reached before the body size begins to decrease and so on, if acidification doesn't become a bigger problem beforehand and so on. And this is the pH change or acidification shown in blue colors. The range goes from about 0.05 to minus 0.05 to minus 0.6. This is for RCP 8.5. So this is again 1986 to 2005 period compared to, or the other way, 2081 to 2100 period compared to 1986 to 2005. So various species that are affected include mollusks and crustaceans, cold water corals and warm water corals. We didn't talk about the difference. Cold water corals are basically not reef building corals. They are individual clumps, whereas warm water corals build big reefs and support a lot of symbiotic life and so on, whereas cold water corals typically are deeper in the water and they don't host such a big biodiversity. Okay, so again, get a sense of how many issues you have to worry about as you go into the future. This just shows the same thing in a bit more detail, but you have to be careful because this was done, I think, with only one model. There are not many models right now which can do these kind of projections. So this is looking at the PCO2 concentration going from the control situation to higher and higher concentrations, and this is the percentage of species that will have positive effect, no effect and negative effect. And the main thing you want to remember is that the percentage of species having negative effect goes up as PCO2 or concentration of CO2 in the water goes up, and it is much worse for mollusks than crustaceans. Cold water corals will have huge negative effects because warming and CO2 is bad news for them, whereas warm water corals may have some chance with some positive effect, but largely a negative effect. Okay. This is the impact on food security and crop yields. So many models are used with many scenarios, and you look at impacts of temperature, precipitation and various other combinations of soil properties, soil moisture changes, extreme rainfall and so on. So when you start in the first few decades, in the current next 10 years or so, for example, there are many models that are depicting positive changes as well as negative changes. The crops considered here are mostly wheat, maize, rice and jowar. I think those are the four ones. But the main message here is, as you go into future decades, the models that say there will be some positive effects are very few, and almost all of them will have huge negative effects ranging from, depending on the percentage yield projections, from total loss -50 to -100% to 0 to 5%. Essentially that means as we go into the future, no matter how much rainfall may increase, the warming will begin to essentially create huge negative impacts on crop yields. This is a big problem. So let's look at the slowly transition into impacts, but how is the potential for reducing the risks? How do we do that? Essentially we said it is either through mitigation, in which case you are directly trying to reduce carbon emissions and accumulated carbon in the system, or adaptation, where you are taking measures which are going to deal with the changes that are happening anyways. So without saying what they are, I will come to it next. We will look at the various regions again, just to keep up with the way we have looked at the maps. So again, regions, the polar, North American, Europe, Asia, Africa, Central, South America, the oceans, small islands and Australia. And the systems we looked at before were also physical systems, which include things like glaciers, snow, ice and permafrost, rivers, lakes, floods and droughts, coastal erosion and sea level effects, and biological systems like terrestrial ecosystems, wildfire and marine ecosystems, and human and managed systems of food production and livelihoods and health and the economics, of course. Okay. So, the ranges shown here are for present. So, the risk level goes from very low to medium to very high, that is the scale, and the projections are made for the where are we presently, what is possible in the near in terms of changes, risks and adaptation. So, how can we reduce, what is the potential for reducing the risks, and long term where we are looking at 2 degrees centigrade warming and 4 degrees centigrade warming. So, the solid colors here in every panel is the risk on that scale of very low, medium to high, and the striped regions are basically the risk level if you have only the current level of adaptation and no new thing is done, but this range in each case shows the potential to reduce that risk with additional new ways of adapting to change. So, we will see what those possibilities of adaptation are in coming into the future. So, the main thing you want to notice here again, without going into too much details, is that different regions have different emphasis. This is not exhaustive, this is just to give you examples. So, these are basically for example purposes. Okay. So, risks for health. So, in polar regions you have ecosystem risk, we talked about Arctic ecosystems and sensitive systems, risks and human well-being, and from unprecedented challenges from rate of change. So, polar amplification is going to make the rate of change very fast in higher latitudes. For rich country like North America, you have wildfires which are already dominating. If you look in 2018, the largest fire ever is burning in the US, in western US. Heat related human mortality, again there is a distribution. So, there are already studies which show that poorer people suffer more than rich people because they do not have access to AC and cars, they have to rely on public transportation and so on. Increased damages from coastal and urban floods. So, the regions that are in the face of hurricanes obviously face increasing sea level and storm surge and so on. In Europe, you have examples of damages from rivers and coastal floods. There will be water restrictions. Germany this year is having severe water shortages because of shifts in rainfalls, and increases in damages from extreme heat events and wildfires. So, in 2003, when more than 35,000 people died in France, they were shocked that such a country is able to be so susceptible at such a high level to heat waves. Since then they have had other heat waves. So, everybody now realizes that they are not as risk free as they imagined. Over Asia, you have flood damages to infrastructure, livelihoods and settlements. Again, examples of 2018 floods are very clearly seen in Japan, China, India. This year has been flooding pretty much everywhere, including in Africa. Heat related human mortality. We know that heat waves in India are a huge problem. Increased drought related water and food shortage. We already know that this is becoming a bigger and bigger problem in our own country. In the ocean, you have distributional shifts and reduced fisheries catch, we already talked about. Coral bleaching and mortality, coastal inundation and habitat loss we talked about. South America, Central America have again water issues, food production and equality issues, and they have also vector-borne diseases, everything we have like dengue, chikungunya, malaria, cholera and so on. In Africa, compounded stresses on water resources. There is many issues here. Many countries including India, China, US have bought land in Africa for their own food security. So, in the future they want to go there and grow food and bring it back. Will this work? We do not know yet, but a lot of people have bought agricultural land. And there is reduced crop producibility and livelihood and food security. So, these regions where you had piracy and so on, and lot of unrest, civil unrest, so on, are warming very fast. Chlorophyll is decreasing, fisheries are decreasing. That's already happening. So, projections are no good. But in each case, you can see, for example, risks to ecosystem here, there are no adaptation potentials that we can show here, neither in the near term nor in the long term. Whereas other examples shown here have various levels of adaptation potential. There is various ways to reduce the risk if we plan properly. So the same in Africa, vector and waterborne diseases, many attempts have been made to reduce malaria because still up to 2 million children die from malaria every year. You think it can just be solved by using nets, but due to various reasons, nets are not used or not available, and DDT was banned, which was used for killing mosquitoes, but now there is some discussion that maybe it should be brought back in limited amounts. DDT is a carcinogen, which means it causes cancer, so it was banned, but maybe it's an effective way to kill mosquitoes and not increase cancer risk. So such options have to be considered as well. Small islands, of course, sea level is a big problem for them, coral bleaching and so on, ecosystem, their dependence on fisheries is very high, and since they are at low levels near the sea level, the coastal erosion and disappearing islands are also very common. Australia has its own set of problems, including the Great Barrier Reef, which sits right there. Its vulnerability to El Nino is very high, and so on. So this is a brief introduction to looking at now the risks in various regions, and this is also important to remember. All global warming is local, so all risks will be region specific. You have to, even within India, Odisha will have a very different set of risks and vulnerabilities compared to Kerala or Maharashtra or Rajasthan, and Delhi will have very different set of risks and vulnerability compared to Uttar Pradesh or Uttaranchal or Uttarakhand or whatever. Okay, so that is very important. I want to add another angle to this global aggregate. We said distribution of impacts, where different regions are affected differently, different groups of people are affected differently, but how does global aggregation happen? We can look at the example of Typhoon Haiyan, which happened in 2011 over Philippines and caused unimaginable damage before it moved on to land and then diminished. At that time, it was the strongest ever recorded typhoon with highest maximum sustained winds, but 2017 shattered that record with the hurricanes growing at the fastest rate, multiple number of hurricanes occurring together, and sustaining at maximum category 5 for the most number of hours, almost like 36 to 48 hours, which is clearly an indication of very warm waters, because hurricanes, typhoons, cyclones get their energy from warm waters in the ocean. There is something called hurricane potential or cyclone potential, which is basically the amount of warm water that is there. So usually when hurricanes go like this, they are so strong that they mix the ocean and bring the cold water, which weakens it, so it moves on to find warmer waters. When it moves on to land, there is no energy anymore, so it gets broken into pieces and dies away. With warming, a cyclone can now mix, but warmer waters are deeper, which means it has more energy, so it can grow faster and live longer. So the ocean warming is directly affecting the strength of the hurricanes, the life cycle of the hurricanes, and the growth rate of the hurricanes. So that is something to keep in mind. So the impact of Haiyan was not just local. There were many debates about who should compensate Philippines. Philippines had a typhoon hit it at a strength that was much more than possible in a natural environment, which means global warming contributed to making it more damaging. Who is responsible for global warming? Can they pay for the damage caused over the Philippines? So some discussion did happen under IPCC and UNFCCC. It was called Green Fund and Damage Fund and so on. Various names were given. It has not fully materialized, but basically it had to look at the amount of damage done over and above what could be expected by a natural level typhoon. Obviously, it gets very difficult to see how much that additional cost is in recovering, but much more importantly to say who is to blame for it and who will pay for it. Okay, that's not an easy problem. Nonetheless, the global aggregation happens. If you look at the modeling of supply chains on how export from, let's say, Philippines in the wake of typhoon affected various economic activities in other countries. 6% of all US production relies on supply from the Philippines. Okay? Philippines exports a lot of coconut oil, which has fallen since typhoon and did not recover for several years. Other countries which have reliance on the supply from Philippines, 21% of the US production could suffer indirectly from supply chain problems. So if you have one product not supplied and that affects production of one quantity, that begins to cascade and it begins to impact other countries. So India is not directly impacted, but impact on US begins to impact India indirectly because India imports things or India exports things that are not needed anymore when production is down. So it's very intricate global system. So loss and damage in one place is not just limited to that place. Now it immediately cascades through the supply chain to the global scale. That's something to keep in mind as to who is vulnerable and how vulnerability of one region or one country affects another region and aggregates globally. See you next time.